All right, good afternoon everybody. This is our last presentation in this session. Our next presenter is a 7-year veteran of the Django core team and president of the Django Software Foundation. This year he was lead organiser of DjangoCon Australia. When not contributing to Django, his hobbies include asking questions at conferences. To speak to us about something that isn't Django, please welcome Dr. RussellKeith-Magee.
Okay, so thank you all very much. As Benno said, I'm RussellKeith-Magee. My day job is as CTO and co-founder of TradesCloud. We're a cloud provider of services, software as a service to tradespeople, doing back office organisation stuff for plumbers, electricians, that sort of thing. If you're interested in migrating to Perth, we're likely to be hiring soon, so come and have a chat. Or if you're already in Perth, come and have a chat to me. And as Benno said, that's just my day job. In my spare time, I'm a core developer on the Django project. I have been since January 2006. I'm president of the Django Software Foundation since 2010. For those who don't know, the Django Software Foundation is the IP legal fundraising arm of the Django project. But for a twist, Django isn't why I'm here today. I got all my Django juice out on Friday at the mini conference, and I'm here today to introduce you, or if you're old enough, reintroduce you to a somewhat neglected corner of Python Standard Library, a module called Tkinter. Why on earth would I want to do such a thing? After all, to quote the Python wiki, Cameron Laird calls the yearly decision to keep Tkinter as one of the minor traditions of the Python world. That is to say, Tkinter is regularly put on the executioner's block, but is saved at the last minute. I would like to use this opportunity to mount a defence of Tkinter, and more than that, I'd like to suggest that we should all be using it a lot more than we currently are. So, what is Tkinter? All right, Tkinter is Python's interface to TK. What's TK? It's the graphics toolkit that came as part of Tcl. For the young'uns in the audience, Tcl, or the tool control language, is a scripting language. It's a similar sort of vintage to Python itself. It was started around 1990. It was very popular in the UNIX world in the 1990s. Its raison d'etre was to be a common scripting language that you could embed into other UNIX tools. Now, UNIX was just sort of coming into its own because of the freeing up of BSD and Linux coming on, and X Windows was around, and Usta had this idea about sort of a visual basic for Unix, essentially, that we could have this common language to control all these tools. Now, as a language, it's a bit of a queer, odd language, but it has one very, very interesting property. Every data type, including code, could be manipulated as a string. And this made it very, very easy to integrate with other systems, because you only really need to implement a string processing interface to actually get that binding happening. Now, that's part of it's designed to be easy to integrate, so it was an easy to integrate language. And essentially that's how TK works. As an engine, TK can display GUI windows, dialogues, buttons, and so on, and Tcl interfaces with TK using a string layer, or using string interface. And it's the simplicity of that interface which is what makes it interesting from our perspective as Python developers, because there are TK interfaces to Perl, to Ruby, as well as Python, because it is so easy to write an interface. You pass strings to the TK engine, and windows appear, and buttons appear, and lo, your brand new language has a fully functioning graphics toolkit for building user interfaces. So, on paper, this sounds fantastic. Why is the Python wiki so unenthusiastic? Well, like all software, TK has evolved over time. If you're of a similar sort of vintage to myself, then your memory of Tcl TK is probably something a little bit like this. Times New Roman text, regardless of what operating system you're on, colours that do not even begin to remotely approximate system defaults, the very best icons, that XBMP icons that money can't buy, extremely primitive widget sets. You could get buttons and lists, but no trees. They were all rendered using motif widget styles, and I don't know if any of you have actually remember using motif. Essentially everything in motif was a button, so you would end up with, when you got to things like checkboxes, it wasn't a box with a check mark in it to tell that it was on, it was a box that would look like it was pressed, or a box that wasn't pressed. And if you had two of them next to each other, and you only had two options, you would be hard pressed to tell which one was on and which one was off. And so that was regardless of whether you're on OS X or Windows or GTK or Qt or whatever else is your underlying widget set. At the API level, it had a mind-numbingly complex layout API using this approach called pack, and there's a bright shiny penny to anyone who can actually explain how the hell pack works. And to make matters worse, the documentation was the usual mid-90s open source standard, which is to say they existed. So why am I being so bullish on Tkinter? Well, two things have changed. Two very important things have changed. The first is TK 8.5. Everything, if the last time you saw Tkinter was in the 90s or even in the mid-noughties, TK is not the same anymore. TK 8.5 came out in December of 2007 and introduced something called TK Tile, which was a new theming engine, which meant that system colors, system fonts, system widgets now became the default style when you started laying out your user interfaces. And so as a result, dialogues look like system native dialogues. Windows look like system native windows. And in the case of the dialogues, more often than not, they actually are the system native dialogues. So when you have a file widget or open file widget, you're actually using your operating system's open file widget, not some weird created thing that some UNIX TK guide thought might be a good idea built-in motif. There's also a new layout system called Grid, which, unlike Pack, makes sense and is a lot closer to the sort of layout systems that you'd be familiar with if you've ever done any sort of GUI programming in an API like Java Swing or something like that. And the widget set is now a lot richer by default. It's not perfect. There are still some omissions that would be useful to have, but it definitely covers a lot more of the basics. At the very least, you have a very good canvas widget, you have a very good tree widget that you can now use. The second thing that's changed, the docs don't suck anymore. An unofficial website called TK Docs has emerged. Someone who actually is a TK fan, and it is, quite frankly, awesome. It is both tutorial and reference. And the docs don't assume it is literally TK docs, not tickle docs about TK. So all of the examples they give are cross-language. So every example is given in Tickle, Perl, Ruby, and Python. Now the docs aren't complete. It is a work in progress, especially when you get to the reference section. But even in their incomplete form, they're pretty good, and they can give you at least enough of an indication of where in the TK official docs you might want to look for certain other details. Okay, so one does not simply TK-enter. Well, yes, one does. Let's walk through an example. In this case, I'm actually going to use here the example from TK Docs itself, the first tutorial from TK Docs. It's essentially what we're going to do is build an imperial to metric feet to meters converter. So, step one, a man, a plan, Panama. Sketch out the GUI we want to build. We're going to have a single dialogue. It's going to pop up. We're going to have a text input to say X feet is equivalent to Y meters, and a big calculate button. You press the calculate button and magic happens. We then need to sort of look at this and say, okay, well, how can we lay this out? What's the sort of the arrangement and alignment structure we want to have inside that? Well, okay, we can divide this into a grid. We've got a 3x3 grid there. We've got a line for one widget, a line for the second widget, a calculate is on the third line. The calculate button can probably sit in the middle of that block. The feet and meters, we need to stick to that side of the column they're in. The middle column, when the window expands, we want the middle column to sort of grow to absorb the additional space. We don't mind if that middle column gets bigger, but the two side columns, you want to keep about the same size. And the is equivalent to, we want to stick to that side of the window. Okay, so that grid will form the basis of our layout and actually putting this whole widget together, putting this whole window together. So, what are we going to do now? We're going to open up a Python shell and start writing some TK code. Now, you can actually do this in a live Python REPL shell, and you can watch the window get built up as you're typing these Python commands. So it won't be interactive until you actually say run the event loop, but you can build the window and watch it happening. So, okay, we import Tkinter and we import TTK. So we've got all the widget sets. The TTK is the extra native styled widget set. This code is in Python 2. Python 3, there is a subtle change to the naming of the import. So again, the TK docs are actually in Python 3 by default. So if you want to see the changes, hunt them down. First step, we need to initialize our root window. We create our root window, TK, and we set its title. So we now have, at the end of this, a window with a title on it. Next step, we set up our mainframe. That root window is essentially a container with nothing in it. And by default, it doesn't have any style. It's just a white window. If we want the window to look like a window on our operating system, we need to stick into it a frame to which we can then put additional content. So we define ourselves a main frame. Every widget has a parent, so the frame, its parent is the root window. And we're going to say, okay, around the outside, around the inside of that frame, we want to have some padding, north, south, east, west, same as you would for HTML padding. We're then going to say, okay, this main frame is in a grid. It's on its root, on the root window's grid, and it's going to be in column 0, row 0, and it's sticky to all 4 edges. So that means that the main root window is a grid of 1 square, and when it expands and contracts, this main frame is going to stick to all 4 sides. So essentially this main frame is going to end up being exactly the same size as the root window always. And lastly, we configure the root window's grid to say column 0 has a weight of 1, row 0 has a weight of 1. What does weight mean? It means where does the expansion go when the window grows. Okay, so weight 1, essentially the weights are then distributed. If you've got multiple columns, the weights are distributed amongst those columns. If you've got one column that has twice the weight of another column, then when the window expands, twice the expansion will happen on that side as will happen on that on the second one. We'll see a better example of that in, when we start configuring a second grid later on. Next step, we need some input. Okay, so what we're going to do is define a string var, which is a data placeholder. It's like the model in a model view controller, and it's where the view, which is the widget itself, gets its information from. If you change the widget, the string var will change, and if you change the string var, the widget will change. We then define ourselves an entry widget, which is TK's version of a simple text field, and bind it to the string var. And we say, okay, this text input is going to have a width of 7, so that's how many characters we're going to allow this widget to have, bound to the feet string var. And we stick it on a grid because we know our original grid position. This is going to be in column 1, row 0, so in the middle on the first row, and it's sticky to the west and the east. So it will stick itself to the left and right side of the window as it expands, but it won't on the north and south. So it'll stick in the middle essentially, or stay in the middle. Next, we need somewhere to put the results. Okay, so we're going to do the same thing here as we did to capture input, but this time we don't use an entry, we just put a label. So we're just going to print the output of the calculation. The label is just a piece of text. It's bound to the meters string var, so when you change the value of the meter string var, the label will change as well. And we're going to stick it in column 1, row 1, so it's going to be in the middle of our 3x3 grid that we have on our main window, and again, it is sticky to the west and the east. We then have our bits of decoration around the outside, 3 other labels. These ones aren't bound to text vars because we actually just wanted to have a piece of text that says feet, or says is equivalent to, or says meters. They're stuck in column 2, row 0. So it's the top right square of our grid, sticky to the west, so it's going to stick to the inside. Is equivalent to is column 0, row 1, so 1 row down on the left-hand side, and sticky to the east. And meters, column 2, so on the far right, on the right-hand side, 1 row down, sticky to the west. And then we do the heavy lifting. We say, okay, we've got a function that actually does our feet to meters calculation. Now, I'm being a little bit lazy here. Feet.get and meters.set is manipulating the feet text var and the meters text var. They are being used here as globals, which is, I will admit, lazy. If we were doing this for a serious app and not just a, hey, let's demo this quickly, all this stuff would be wrapped up into a broader class, and we'd be using self.feet or self.meters. Or we could use functools.partial to bind a feet and a meters object into the function call. The important thing to basically note here, though, is that calculate is just a function. It is a callable, and the callable is what is going to get invoked when we hit the go button. We're going to put a button, TTK button, in the mainframe. Its button, its text will say calculate, and when it is pressed, call calculate. Call the calculate method. We're going to stick it in the grid, bottom right, and it's going to be sticky to that side. We're also, just to make everything nice and easy, we're going to bind a keystroke to it as well. So when the root window senses that enter or return has been pressed, that will also call the calculate button. So regardless of whether you click on the button or you press enter, the calculate method's going to get invoked. And at this point, we can basically let it rip. We do some last little bits of setup. We can, the widget tree has a sort of self-reflective property, so you can say, okay, let's have a look at all the children in the mainframe and configure them to have the same amount of padding, so an X and Y amount of padding going to be on all of them. We can specifically say, give the feet entry box focus, so the cursor is going to be stuck to that window initially. And we're going to configure our weights. Now here, we're going to modify the weight of column 1 to be 1, so all of the weight will be stuck to the middle column. When you expand the window, it means that of your 3 columns, all of the expansion will happen in the middle. The outside 2 columns will basically stay exactly the same width. And then you run the main loop, and off you go. You will have a running application on your desktop that's doing the calculations. Yep. Little thing to note there, that is a blocking call. Okay, so your GUI won't repaint unless it's in the main loop. Your GUI won't repaint unless it's actually running through the main loop. So if you have an expensive calculation, you kind of need to slice it up into smaller chunks so that your window will actually will repaint, or you've got to put that operation into a separate thread so that the GUI can actually paint itself. That's not particularly unusual in GUI stuff if you've ever done like Swing, for example. And the result, you actually get something that on OS X looks like an OS X dialog box. It looks like an OS X application. Okay, so there's a whole lot more. That's a blinding introduction. You can go to TK Docs if you want to see a lot more of a tutorial. You can see a lot more of the sort of widgets that you have access to. There's a lot more in the box. You can have all sorts of dialogues using system dialogues. There are menus. You interact with your menus and actually make it interact like with your Mac menu can be up there. There are a whole lot more widgets, including an extremely rich text widget. How rich, shall you say? It takes you about 5 lines of code to get full syntax highlighting in a text widget. There is a really, really rich canvas widget as well, which is you're drawing boxes and interacting with boxes on a screen, or with graphics, vector graphics on a screen. And if at the end of the day you find that something in Python doesn't exist, you can actually get down to the raw TK level. You actually have access to the raw bindings to poke what you need to poke. And the thing that's worth reiterating here is that it's all in the standard library. If you have got a Mac, you've basically got this sitting there in the standard system Python. If you've installed Python from other operating systems, it's there in the standard library. It's a battery that is there in the box for Python 2 and Python 3. No dependencies, no binary compilation, nothing confusing to do there. Okay, so what? Well, I've got a theory. And to explain my theory, I want to walk down memory lane, or at least my memory lane, a little bit. In 1988, my first computer was a Commodore 64, but I really here we go. I really cut my teeth programming in the late 80s using the Ball and suite. So Turbo Pascal, Ball and C++, languages like that. And there were 2 very notable properties of these tools. They had really, really fast compilers. That's sort of how Ball and made its money, was with really fast compilers. And they had a very distinctive user interface. It was an 80 by 25 full color cursors interface, which sounds primitive now, but at the time that was cutting edge. It was really pushing the limits of your CGA 4 colors monitor. And it was really pushing the hardware in terms of what you could do. It was a full IDE in that sense, but a really good compiler and a really good interactive debugger so that you could see what the hell was going on with your code. In about 1994, I discovered UNIX and the GNU toolchain. GCC, another really fast, really good compiler. And GDB exists. It has almost no user interface at all. It is an extraordinarily powerful debugger, but almost toxic from a user interface point of view. There is 1 line of context every time you write a line of code, and incredibly arcane syntax for setting breakpoints into a piece of code. Around 2000, that was where I basically started taking Python somewhat seriously. And Python took everything it could from the Unix world. Under the hood, it's got a really powerful debugger. PDB is an extraordinarily powerful piece of kit. But it's got the same glistening user interface as GDB. If anything, made worse because in order to debug my code, I have to deface it. What? And okay, we go through to 2013. IPDB, PDB++ make things a little bit better. They give you a bit of context on the screen. PUDB is trying to resurrect a cursor-style user interface. WinPDB exists, but you've got to get WX windows working, and there's another bright, shiny penny for anyone who can get that happening. Or you have your fully fledged IDEs like Visual Studio or PyCharm and languages like that. My theory is that cobbler's children have no shoes. 25 years after I learnt to program with a cursors-based debugger, I'm actually telling people as part of professional practice to just put some print statements in to help you debug this. And there's all the other things that I'm doing on a daily basis, testing, profiling, coverage, things that I wasn't doing 25 years ago, but for which I don't have any kind of user interface. So over the last 25 years, the quality of the development tools, especially in the Unix open source space, essentially haven't improved. And if anything, they've got a little bit worse, despite the development of Retina displays and window graphic systems and a deeper understanding of user interface and user experience and the effects that a humane in user interface can have on productivity. We're applying almost none of that to our own tools. So why is that? Some of it, I think, comes down to a misinterpretation of the Unix philosophy. Unix tells us to do one thing and do it well, which is a fine philosophy. GCC compiles, it just compiles and it does a very good job. GDB just debugs and does a very good job. grep and sed do just one thing. But the Unix philosophy doesn't say that your user interface has to suck as well. If you're dealing with grep and sed, or even GCC for that matter, yes, a command line interface probably is the most appropriate user interface, or at least one of several appropriate user interfaces. Why is a single line of text the natural interface for a debugger? My theory, we can fix this. We have the technology, or more specifically, we have Tkinter. If you've got Python installed on your laptop, you have at your disposal a rich cross-platform set of GUI tools with a clean Pythonic interface. And better still, and this is where I think it really gets powerful, if you've got a GUI tool installed in your virtual environment, it's as easy to install as saying pip install my tool, and that tool will run in your virtual environment. You don't have to spelunk around with configuration settings dialogues in your IDE to try and work out how your IDE is deciding to run your code in a particular way. You just use the same user environment that you're using for everything else. Now, it's not just a theory. To prove my point, I'd like to publicly announce here something that I've been tinkering with for a little while. Testing. My talk at DjangoCon the other day was about testing. It has been something that I've been passionate about ever since essentially I left university and discovered testing by being thrown headfirst into it at my first job. Here is the user interface you currently have for testing. You run your test suite and you get lots of little happy dots going along there. And okay, I'm running my test suite here. Questions for you. How long is this test suite going to run for? How long's left to run? Which one of those tests was the slow test when it ran? That F that's in there up on about the fourth line down, what was the cause of that? The X that's about an inch along from it, what was the cause of that? Is this something we need to be worried about? The great long of skips there, is that because I've forgotten to install a dependency? These tests that have generated a warning in the middle of them, which test caused that? This is not a helpful user interface for running a test. So I'd like to introduce Cricket. Cricket is a graphical tool to help you run test suites. It's called Cricket. Why is it called Cricket? Well, because test cricket is a very long game and you need all the help you can to make it bearable. How do you install it? Well, at K, you go and you open up your virtual environment, you say pip install cricket, and then you say python -m cricket.django, and it will run your Django unit test suite. It will discover your test suite, and then what's in your test suite, and then it will let you run it. Notable features. Down the left-hand side, you've got a tree full of your full test suite. It has discovered everything that your normal Django test runner would discover. Across the top, you've got buttons to run the full suite. Only the selected tests or the tests that have failed, so you can select items in the tree and say, I want to run that one, and that whole test case class. Along the bottom, this test suite is actually running at the moment. We've got a progress bar telling us how far along progress we are. We've got a time estimate, about 48 seconds remaining on this. A summary of we've passed 389, failed one expected failure, skipped 155 tests. There's actually two trees there, an all tests tree and a problems tree. If you tab over to that second tab, you'll see the subset of those tests that actually have failed, like test non-default cache. This test suite is currently running. So I can select the test that has failed, and I can see the error traceback for that test whilst the test suite is actually still running. I can see from the tree up there, it's a fail, big red F. It's a big red item in the tree as well. All the greens have passed, the blue has been skipped. I can select all those and see the state of the run tests while the test suite is still going. So it makes it very, very easy to see patterns of failure. It's easy to rerun just the failed tests. It's easy to rerun just the tests from a second module or every second test, or run all the tests but disable that one in particular. If you double click on a test entry, it'll take it out of the list of tests that are executed. So it makes it very easy to run your test suite and see what's going on while your test suite is executing. Now, okay, it is early days. It does one thing, but does one thing very well. it runs Django test suites. It has been released as a version 0.1. It, at the moment, doesn't run on Python 3. It only runs Django test suites, supporting both the pre-1.6 and 1.6 test discovery modes. But it does have a back-end API that would allow you to put in anyone else's test discovery mechanism or anyone else's test running mechanism. I have been using this in production for about sort of two to 3 months at this point, just using it on a day-to-day basis to sort of iron out the edges and see whether my theory actually worked. And my experience has been that it's made running my test suite a whole lot easier. There are some crusty edges that still need to be taken out of it, but as a principle, I think I've demonstrated to myself, I've satisfied myself that this can actually work. So, at this point, with the command line, I'm sure there are at least 2 people in the audience itching to yell out. One of them wants to yell PyCharm. To say, well, if you want this, just go and use an IDE. No, yes, IDEs do have test runners, but my experience is that IDEs are a different sort of philosophy to building. They're about having one great big tool that does everything, and they've got to be configured to do them the right way. I actually do like the Unix philosophy. What I don't like is the Unix user interface of everything needs to be done at the command line. I like using really rich editors, and most IDEs that I found don't have rich editors. They've got okay editors, but not fantastic ones. And I like to keep using the editor that I like using, and I want to be able to pick the test runner that I want to run. The other person in the room wants to run something like py.test, and yes, py.test does expose a much nicer command line experience, better rendering of exceptions and things like that, but again, it's still command line and you don't get to see all the stuff that's happening whilst the test suite is running. There's probably also someone in the room who wants to yell Emacs, but we'll just ignore them. My point here is the Unix philosophy is right, but it doesn't mean we have to be constrained to the text console. There are good reasons to have command line tools. Compilers make sense as command line tools. Anything that's fetching and processing, like grep, awk, sed, curl, they make sense as command line tools. And it makes sense to have command line tools as a fallback when you're operating remotely. But this doesn't mean that everything needs to be stuffed into a command line tool. We can have humane user interfaces and humane interfaces for things like test runners, debuggers, coverage tools, profiling tools. We can have them cross-platform, and we can have them out of the box, easily installable into virtual environments. So that's my pitch, that's my theory, and Cricket is my attempt to demonstrate that the theory isn't completely abstract. I'd like to, at this point, open up for questions.
Does Russell have a question for Russell? No, sorry. Richard.
Is it on? Is it on? Excellent. Yep. Excellent. I love it. Do you have any idea of you said there's like back-end stuff for other test discovery.
Yep.
So I am a heavy user of nose, and I also use it with the twisted bits to do my twisted testing. It's not pretty.
Yep.
Do you have any idea of the effort I'll need to expend to have that being run, or if it's possible to run that stuff with Cricket?
Okay, I don't know nose well enough to better answer canonically, but I suspect not a great deal. The Django wrapper is on the order of about 50 lines of code, I think, and it's mostly essentially saying you need to have two commands, one which echoes to the command line, at the command line level, echo a string, dotted string version of all the module names that are actually going to be tested that can be identified as targets, and then a runner that can take a list of targets and execute them. So it's not a huge job. I can walk you through, I can show you the code for the Django runner, or the code's up there for the Django runner. It does back off a little bit of what Django's test runner does. It's made easier by Django's test runner, because Django's test runner, essentially what I've done is take it, subclass it, and say, for command A, do everything, but just don't run the tests, print them. And the second one, run all the tests as they're given to you. So I suspect the answer is not a lot of work. I have not actually done it though, so anything between theory and practice, etc.
Supplementary question,
yes?
If I may. So in the tree widget at the side, I can double click a test just to run that one test?
If you double click, we'll actually turn it off, but you can click it and say run selected. And I have no keyboard bindings on this at the moment.
Okay.
I do not profess that it is the best user interface. I think there's probably a lot of work that could be done. It is the user interface that I've built to test around with it, and I'm certainly open to suggestions about whether enter should be the run binding or the turn off binding, or whatever.
Okay, I think it's awesome. Thanks.
Mm-hmm.
Hi, I'm a PyTest user, but I think I would be super interested in seeing that work with PyTest. Mm-hmm. And this might be kind of the same as asking about Twisted, but do you think that's going to work okay with tests being farmed out and parallelized in terms of seeing the, what do you call it?
The output from it. Okay,
yeah,
so the
results.
interface, and the reason why this actually works as a, it runs in your virtual environment is essentially what it is a Python script that starts in your virtual environment that then starts sub-processes which inherit the same Python environment, or the same Unix environment essentially, that then do things, and then there's a sort of there's a pipe back channel which reports this test has passed, this test has failed, this test has got this warning in it, and there's a protocol for passing that information back. So as long as your runner, or you can run your tests in such a way that the output to the screen is essentially JSON text, JSON strings described in a particular format, then you can integrate it. It's whether that is easy or hard depends more upon the test tool you're running it with. If you are farming it out to somewhere else, that shouldn't matter as far as I understand, as long as your runner is able to get that information from whatever remotely it's running and pass it back to the GUI through that back channel. Okay. Yes.
Thanks for the talk and the Turbo Pascal screenshot. Lots of memories for lots of us, I'm sure.
Exactly.
So having written the app now in a modern version of Tkinter, what sort of dark corners or gotchas did you find along the way that we should be aware of?
The dark corners that I hit are, okay, so there are a couple of refresh issues that it has some interesting refresh behaviours in some places. I suspect that is sort of more on the lines of a bug with Tkinter rather than actually or a bug with TK rather than being an inherent problem with TK as an approach. I can actually show, if I close this out, I can bring it over. Here is a test suite. So for example, there isn't a widget for a panel separator, or there is, but it's it doesn't have a visualization that's there. And it does some interesting things with dragging. Oh, now it's not, there we go. So if you drag hard enough, you can lose, no, it's not going to do it for me, there we go. It's possible to lose the handle, which you shouldn't be able to do.
Yes.
The biggest one that I hit, Ro, is literally the same thing you get on any user interface stuff, is that your event loop must do lots and lots of very, very small things. You can't do anything complicated in your event loop. And that requires a bit of mental bending, but it requires mental bending on any user interface toolkit, essentially. So you take your heavy lifting, you move it into a separate thread or separate process, and then you have a communications back channel that says turn on the widget, and that's all it does. The other area is there are some, if you hit the edge of, if you need a widget that does something that isn't out of the box, you kind of have to hit TK natively pretty quickly. So I have been tinkering with a graphical debugger as well. So this was let's prove I can do it in TK at all. Okay, my real goal is I want to build a debugger that actually debugs code rather than doing one line at a time. And to do that, you need a line count rich text widget with syntax highlighting that isn't editable. And the rich text widget that TK gives you is editable by default and can't be made uneditable. You actually have to get into a fairly low-level TK level to eat the editing messages that are coming through. It can be done in about 15 lines of TK. The secret is finding the 15 lines of TK. And I'm not enough of a TK expert yet to make that sort of really natural. So that would be probably the only two things I'd really flag there.
Thanks.
Okay.
Hi, I was just going to say, the last time I used TK was back in 1996, and I actually enjoyed the pack layout. Sort of.
Oh, okay, right. So you can explain it to me sometime. That'd be great.
I can't actually remember it, but I just remember back at the time it kind of fit my mind well. I'm not sure what that says about me. But the question I was going to ask is, how did you find TK as just a general API? I mean, my memory of it was that it had just a very low kind of mental overhead to sort of get things done.
Yeah, okay, so TK, so TK I can't really comment because I've only really been using it through Tkinter. But it is a very, it is a very Pythonic interface in the sense that you've got a button. I want to put a button on the screen. I want to put it there. I want to put it there in the grid, and when you press it, call this function. That's what I want my interface to be like, and like I said, you can do that in a REPL shell and just bind the callable into the method and off it goes. So yeah, it was a very natural interface to get into. So yeah, I have quite enjoyed using it. I've done plenty of GUI programming in the past with Swing and Qt and stuff like that, and this is probably the fastest UI code I've ever been able to just get off the ground with a running product by virtue of it being in a language I like that you can rapidly turn around, etc. So.
Really simple one. Visual designer.
Yeah, I don't have one.
Does one exist?
Sorry?
Does one exist for Tkinter?
Tkinter, I don't know. I think there are some for TK, but I'm not sure. Not that I've actually actively gone looking for. Certainly would be interested in seeing if there was one, and that itself would be an interesting TK project to sort of meta right if there isn't one. So, yeah.
Active state Komodo as well.
Has it? Okay, active state Komodo has one apparently. So.
Thank you, Russell Keith-Magee.
Thank you.